Hello, and welcome to another episode of Earth911's Sustainability in Your Ear, the podcast conversation with a changemaker working to accelerate the transition to a sustainable carbon-neutral society. I'm your host, Mitch Ratcliffe. We're going to talk today about buildings. They're a major contributor to greenhouse gas emissions. The $5.8 trillion a year building and construction sector, including ongoing operations of buildings, is responsible for 38% of the world's energy-related CO2 emissions, according to the United Nations Environment Program. The International Energy Agency estimates that emissions associated with construction and buildings needs to fall by 6% a year by 2030 if humanity is going to avoid crossing the Paris Accord's target 1.5 degrees Celsius threshold, which represents the increased likelihood of disastrous climate impacts, extreme weather, and what we are often hearing are tipping points that change everything about our lives. And we're not making that necessary progress, despite the fact that green buildings are projected to account for $24.7 trillion in new construction in this decade. Architects and contractors need much better tools to design and test buildings, plan efficient building projects, and optimize the use of materials while minimizing waste. Our guest today is Håvard Haukeland. He's the co-founder of Autodesk Spacemaker and a senior director at Autodesk, which is the pioneer and leading provider of computer-aided design. It's also called CAD, and other design tools used by architects and builders. Autodesk tools also power many of the breakthroughs in animation and special effects you know from movies like Star Wars. Spacemaker is an artificial intelligence platform that can analyze architectural designs, blueprints in other words, to identify potential improvements that reduce energy consumption with design changes that change the power requirements during the operational life of the building. It also has analyses for things like the benefits of a solar panel, microclimate interactions, sun, wind, natural light, noise, and views out the window. In short, the operational energy analysis looks over the design and provides predicted operational energy use as the architect works, suggesting the impact that different types of, for example, insulation can have, how different kinds of windows will perform based on the dimensions of the entire building. The Spacemaker Energy tool was introduced in October. It's available in beta now, and it works with other Autodesk tools to speed the green design process and enable efficiencies during construction. You can learn more about Autodesk and Spacemaker at www.autodesk.com. Welcome to the show, Håvard. How are you today?
Thank you. Thank you so much. I'm doing great. How are you?
Good, good. Now we're speaking to you. You're in Oslo. That's where Spacemaker was founded.
Yes, that's right. It's Christmas-ish. It's winter. It's snow. It's -6 degrees Celsius. So,
it's cold here in the Seattle area too. We've even had snow already. So let's jump into this. A lot of people still think of architects and contractors as working from blueprints, and the nature of construction and design has changed entirely, mostly due to the desktop computer and then the cloud. Can you tell us how the industry works today and about the role that particularly artificial intelligence is beginning to play in the planning and construction of a building?
Yes, absolutely. I mean, the industry does not work in one way, unfortunately, should I say. There's people who still use Blueprint, and then there's people who use AI. So you have the whole spectrum. And I think one thing that we've really learned is that change takes time in this industry. And BIM was, as an example, BIM was introduced 20 years ago or so, and adoption is still globally only at 30% or something. So many people still use 2D tools or even hand drawings. There's physical models still cut out in foam or cardboards. I used to make those myself when I worked as an architect, and, sketches are drawn by hand.
Right.
But the trend, luckily, is still in the direction of digitizing the workflows. And one thing, like you said, is the cloud, which is a big change, going from working on your local computer to working in the browser, but also what that enables in terms of collaboration, where you can have multiple people working in the same model, or sharing data and sharing information. But also the power of the cloud, where you can basically run thousands of computers in parallel instead of being limited by the one you have under your desk. There is a change from files to free data flow. So basically, instead of having to work within your tool, you can now, there is a trend happening where you can work more with your data flowing free between different softwares. There's more and more people interested in making data-driven decisions instead of, the traditional way of using your intuition and the experience you have yourself, but basing it more on richer data sets.
Well, and that's really important. That, right there, I want to particularly hone in on this because I've actually worked on some projects involving this as well. And what people can do today is build a building together from all over the world and see it change. So if, for instance, an architect says, if we change the window configuration here, you could save this much to the client, and at the same time show it to them.
Yes, exactly. So, from having your tool is, your tool and nobody else can access that model. There's now many different ways that you can collaborate in the cloud and sit, as you say, in each part of the world and doing the changes live. And that's enabled by the power of the cloud and, serverless environment. So I think it's also interesting that, the linear way that used to work before, if you needed, like you say, you needed an expert advice or you want a consultant to check something on your design, the way you did it before is you had to make that person rebuild the model in their tool and then run an analysis like road traffic or wind turbulence or microclimates or operational energy or whatever, right? And then actually run the simulation and then write a report and then send the PDF back to you on email, right? And that process that usually takes days, you can now just do at the click of a button.
So how does an architect or an urban planner use Spacemaker in their daily work? And let me ask you to characterize it. Is it a sustainable design coach for the architect? Is it a library of information that knows what the architect needs? Or is it a Jedi master that reshapes the design sort of auto-magically? Or a little bit of all those things? How would you describe it?
Yeah, that's I'd say it can be all of those, more or less. It depends. It's interesting because it really depends on how the user wants to work. You can either have proposals generated for you, like you say, automatically, or by describing what you need. Like there's systems both in Spacemaker or other tools where you can, have a computer really work as let's say, someone who proposes solutions for you, like an assistant sitting on your shoulder or like helping you get to where you want, right? But you can also work the way that you normally do, where you design something based from your intuition. You have an idea and you want to design it, and then you check it, how it performs, right? But what's interesting is that, some people still think that, or some people still seem to think that AI is that magic black box that solves everything for you. But I think if you take, let's say, operational energy analysis as an example, the AI part of it is not something you as a user need to understand or even actively use. It's just there, making it possible. So what you experience as a user is an analysis that tells you how much energy your building will need when it's done, right? But to make that happen, we have had to run thousands and thousands of energy simulations and then train an AI on all of those simulations until it was smart enough to be able to actually predict the outcome for you instead of needing to do the actual simulations. And which means it can happen instantly instead of waiting for computers to do the calculations, or even worse, like I said, waiting for an expert to build a model, run a simulation, write a report. So the AI enables that to happen, but as a user, you only see that, hey, I drew something and then, wow, this proposal or this design change made the building more energy efficient. But you don't need to even understand that AI makes that happen.
Well, and the other element of this is that many buildings are now constructed virtually before they're actually constructed in the real world. And that's a reflection of a trend that we're hearing a lot about, and we've had on the show before. Michael Jensen from City Zenith was on talking about digital twins. How does Autodesk view the role of digital twinning as an accelerator, not just of new green construction, but rethinking the way our world is built?
Yeah, I mean, it's a good question, and construction industry is the number one consumer of global raw materials. At the same time, there's global housing shortage and a global need for infrastructure. So we need to build more, right? But there's 30% of global greenhouse emissions are coming from buildings, and I think Autodesk believes that digital twins provide the means to transform the built asset lifecycle by really enabling the data continuity between the project phases. So a digital twin gives a multi-dimensional view of how a facility or asset is designed or built, but also how it's performing through its life cycle, right? So as a digital replica is enriched with the operational building data, it becomes possible to actually predict system failures before they happen,
right?
Before the what-if simulations, and provide those rich insights into the operation, the performance, and utilization of the built asset, but also in the very early phase when you're not even sure what to build, right? So what's interesting is that the knowledge that's accumulated can be used to plan the future projects and improve design decisions, leading to more sustainable buildings and infrastructure.
So, when we think about talking about this with a lot of guests, it's becoming clear that we need a model of our world that is accessible for everybody to begin to do the kind of improvement we need to do. But this entails a significant challenge for a lot of companies, particularly real estate management companies, who may not want to share that information because they feel it's confidential. How do we change organizations' approach to their relationship to the information about what they operate, these buildings?
Yeah, I mean, we should think about that, but I'm actually not sure if we need to do that, because what's so interesting is because data is being produced at a speed that we don't see, but that is overwhelming. We're actually historically you needed a lot of information to actually say something about, let's say, a building, right? But there is a change happening where you can produce data easier and easier, right? Meaning that you combine different data sets and together they provide you enough information to tell you about the building. So I don't think that we in the very near future even don't need to have traditional drawings of a building to understand enough of the building in order to make the kind of decisions we do. Because, I mean, just as an example, started off with Google driving around, taking images of the, streets, right? But the world has come really much further after that, where, there's so much data about how people use buildings, and we leave so much digital traces from our work in our life, that also the insides of buildings are actually mapped in some cases, and the data can be extracted and combined with a different data set, and together they provide, what I'm saying? So I think it's interesting that, yes, we should definitely change the minds of people who are protective about data, because open data enables progress. But I think it's also interesting to see how we can work around it.
So it doesn't sound like necessarily we would need to have all the legacy buildings, the ones that are not digitally modeled, ingested into this new digital environment in order to do an analysis. We can, even from satellite imagery, get a pretty good sense of what's out there and start to make recommendations about changes in our built environment.
Yes, we can. And I mean, as an example, if you combine LiDAR data of the world and combine that with satellite images, with machine learning, you can actually understand if it's, let's say, a tree, and how tall the tree is, the diameter, or the shape of the tree. And same thing with buildings.
Shadows it throws, which may cool the building or not cool the building. Yeah.
So there is so many tools that can help us produce data that are being developed as we speak. So yeah,
that's amazing.
But, I mean, yeah, but I still think the more data we have, the better. And yes, most of the buildings that we have 20 years ago are already built, right? So there, even if we need to build a New York every week or whatever it is to meet the needs over the next 50 years, it's still a massive need to transform the buildings we have and learn from the buildings we have. And we definitely need to produce data from those as well. I'm not saying anything else. I just think it's interesting that, if people are protective, the technology industry will always find a way around it in a way.
We can see through the protections is basically what we're talking about, which is an interesting thing. It creates a potential set of tensions in our society that we haven't really accounted for. This is fascinating. I want to take a quick commercial break and we'll come right back and continue the conversation. We're back to continue the conversation with Autodesk Spacemaker's Håvard Haukeland about making the built environment more sustainable by design. Now, Håvard, you've studied construction carefully. You were an architect. What can we do to make buildings more efficient? What are the most impactful changes that we should be thinking about when we build a building today?
Yeah, I mean, efficient is a nice word because it can mean many things, right? It can mean energy efficiency, of course, but it can also mean, material efficiency or cost efficiency or energy efficiency, like, or many other things, space efficiency. But I think if we dive into energy efficiency, which I think is of course, very important and something that's also very interesting because we've been spending a lot of time trying to figure out how we can improve the way people handle energy efficiency. We've very recently introduced an analysis called operational energy analysis. And what it does is it really tells you how energy efficient your building is. And what's interesting is that you can handle a set of parameters, right? It's wall construction type, it's window construction, what kind of glazing, it's roof construction, it's window to wall ratio, and so on. But what's interesting is that one of the really most impactful things you can do is to adjust the compactness of the building. Mm-hmm. So the facade volume ratio. So, if you can have as much compact volume as possible with as little facade as possible, that's what makes the biggest impact. And I think it's interesting to see when you have a model where you can just make changes and immediately see the impact on the predicted energy need of that building. You become aware of these things that you may be as an architect or developer or general contractor or whatever it is that you're working with, but not an energy expert. You can still have enough information to make those decisions, right? You don't need to consult an expert to get those insights. And what's interesting is that to make an impact, you need that information, or you need that information when you're changing the design. Mm-hmm. We believe that, or we've seen studies showing that more than 50% of value creation happens in the early stage, right? What's interesting is that only 25% of technology investments happen in the early stage, but it's really where you can make the smart decisions, but also the dumb ones, right? The mistakes. And that's what we see that, okay, if you can have that information about your energy efficiency when you're tweaking around on your building and you can make those changes so easily, you also make those changes because it's so easy to make the changes, right? And that's when you have the impact. Because if someone tells you when you've detailed every part of the building that it's really inefficient from an energy perspective, it's really hard to make all those changes.
Now, you talked about materials, although the way you described the design of the building, it's kind of like what we really ought to be thinking is building a TARDIS. It's bigger on the inside than it looks. And that's makes the most efficient use of the space. But building materials are becoming, they're changing rapidly. Cement, for instance, is going to be more low carbon. Is Spacemaker able to look at that element of the design during building and say, you should switch to this kind of concrete? Or in the operational phase, could it even go, you have these windows in place now, but new technology, which is so much more efficient, is available that you should consider upgrading? Is that a role that a spacemaker could play in the future?
That's a very interesting question. And what we previously was talking about was the operational energy, and what you're now talking about is the embodied carbon, right? And it's something we work on, and it's very interesting. And there's something that many of our customers have been asking us to dive into, because it is possible to make the same predictions early on and advise the user, right? Because the information is there. It's about providing the user with the information at the right point in time, right? At the right time. So we don't have that kind of analysis now, but we're working on it, and it's there's a lot of potential there in terms of what you can actually advise the user about.
Well, the beautiful thing about the digital world is that you can connect these systems and get deeper insight. One of the things I was wondering about is with regard to the evolution of something like Spacemaker, whether it's Spacemaker or not. I don't want you to have to make a promise you don't want to keep. But could an architect, for instance, expect in the next decade to be able to model the future impacts of changing weather patterns on a building, for instance? If I'm building a building in Phoenix and it's going to be 13 degrees hotter on average, is that something I'll be able to assess as part of my design or ongoing operations?
Yes and no. You cannot. So Spacemaker cannot tell you that your specific area is about to become warmer, so you should take that into account. But what you can do as a user is that you can simulate different scenarios, right? Okay. That's what it's all about. So we have for example, we have a microclimate analysis, and the architect or whoever uses the software can choose which parameters to use in that analysis. You can choose to plot in if it's 35 degrees Celsius or 40 and see the difference, for example, on heat islands. And heat islands occur if you block the wind from airing through the area, and you have direct sunlight warming up a specific area or a specific part of the building, then you get these heat islands that sometimes can get 5, 6, 7, 10 degrees warmer than the surroundings, right? And you want to avoid those. And usually that's something designers are not looking at today. But we see every summer in the news that there's fires. There's, Paris is 10 degrees warmer than the surroundings. And you get these situations, especially in the cities, where the air stands still and you get these heat islands. And I think it's very interesting that you can now model those scenarios in the tool and see, wow, in my backyard, it's actually going to be 7 degrees warmer. And then you can start tweaking your buildings and see what happens, and then see how you can avoid that from happening.
Now, AI needs inputs in a lot of context, information and models to analyze. Where does Spacemaker get its information, and how do you develop the models to support the ongoing evolution of how construction is done?
So, like the simulation I just described, Spacemaker uses local data sources to make it possible for you to simulate, or we have simulated on forehand, and then we train on those simulations so that we can predict for you. But it's all based on the most, what should I say, the available data in that area. So it's terrain data, it's building data, vegetation, but also local weather data. If it's wind, sunlight, weather, rain, like traffic, like acoustic noise from traffic, and so on. So as users simulate the outcomes, meaning it's really up to the user to make decisions based on those results, right?
So but also what I'm getting at is, you just described a lot of inputs that we haven't collected in the past. Is that information being gathered by sensors that are in our environment, or do we need to think about creating an entirely new set of jobs around the capture of this kind of information and things we don't currently anticipate?
Well, that's, if to your first question about sensors, there's many different data sets, right? And some data sets are based on sensors like weather data, but we've not put up the sensors, right? It's typically like a weather center that has the open data available. But in many cases, there are also data sources that are being like in some countries have rich data, some countries have really poor data, and we cannot create a better solution than the data of that country, right? So in some countries, the data is really rich, right? And you can also then have really rich information about the surroundings and your context, but other have really poor data, right? So you need to make easier or simpler predictions. But as an example, there are more and more global data sources that are open and global, like street maps and terrain data and so on. So we're getting more and more. And should we have more jobs of people producing data about our surroundings? Yes, I think so. I think the more data, the better.
Are there types of data in particular that would be high value that we should think about putting people to work gathering?
Well, I think in general, how human behavior inside and outside buildings and how we use our surroundings is of high value in our
anthropological data, basically, is what you're saying.
Yeah, absolutely. I mean, because we base so many of our decisions of what we design on our intuition. And I've heard it so many times that people say, I think this would be a great place if we just add something here or blah, blah, but they don't make data-driven decisions about saying, hey, we've looked at the trend and people tend to use spaces that are blah, blah. Like you don't use the data, but the data is there, right? That's something we were trying to do or trying to help users do is go from intuition-based decisions to data-driven decisions.
As I read about Spacemaker, I thought a lot about CAD, computer-aided design, and its role has broadened substantially since back in the early 80s when I first started to pay attention to this. In fact, one of the reasons Lucasfilm is based where it is it's near Autodesk. Because they were working so closely with Autodesk to develop new technology. And now that technology is available to anybody making a film. Is the capability we're talking about today with Spacemaker, like CAD before it, going to propagate to become just sort of a standard feature, not only of construction projects, but maybe the way we manage our environment?
I think it's interesting. I think in general, history has showed us over and over again that advanced technologies, they start off as expensive expert tools, and then over time they become commoditized, right? They become they spread out to the masses, which is fantastic, right? And I think what's interesting about CAD specifically, since you mentioned it, is it's 40 years since AutoCAD was founded, and I think AutoCAD is still a fantastic product being used by millions of people all over the world, right? And it's pretty interesting because when BIM came, everybody, and 3D modeling, everybody started talking about, 3D modeling just replacing the 2D world. Yeah. Like now we're never going to use 2D world again, right? But still, more people use 2D tools than 3D tools 20 years after. But there is a lot of people that use 3D tools. So I'm not saying that, we found the ultimate tool. Quite the opposite. It enabled us to build 3D models, and then enabled us to work with the cloud, and it enables us to work with these outcome-driven design processes that we're talking about now with free data flow. And yes, there is a revolution happening right now because of all the involvement that has happened within technologies over the latest years, when kind of reaches a tipping point where it becomes mature enough, where you see that the actual starts to have useful, impactful outcomes of all, AI is not a new thing, right? We've been just developing algorithms for 20 years, but it's now starting to become mature enough, right? Yeah. So I think it's really interesting. And yes, there is a revolution happening now. And yes, it will become commoditized. But CAD is still, the history is still important and relevant.
Well, it's going to be interesting to live through the history of what we're about to do, and hopefully we'll make the transition. How can our listeners learn more about Spacemaker?
I mean, they can go into autodesk.com/spacemaker and they can sign up for a trial and just test the tool.
Well, I hope that millions of people end up using this, just like CAD. Håvard, thank you very much for spending time with us today.
Thank you so much, and great to be here.
We have been speaking with Håvard Haukeland, co-founder of Autodesk Spacemaker and a senior director at Autodesk, which is the venerable computer-aided design company. You can learn more about Spacemaker at www.autodesk.com/spacemaker. That's autodesk.com/spacemaker. Now, underlying the conversation we just heard is a very fundamental change in humans' relationships with their built environment and the global environment, as well as the information that we have about all of those things. Earlier generations were used to the idea that the world was largely static. It was unchanging after we would introduce, for example, a new generation of buildings or technology. Once those were in place, we thought of ourselves as kind of static, sitting still. But today, many technologies and all the information we have is evolving all the time, providing a dynamic model of our world that, in addition to solving for existing problems, creates opportunities to make even more improvements. In our new world, new challenges are always available, sometimes whether we want them or not. It's important that we recognize and embrace this change because, as William Gibson, the cyberpunk author, wrote, the future is already here. It's just unevenly distributed. We have these interesting tools available. Solutions are emerging all over the world, and we can bring that together through technology to connect solutions that emerged elsewhere to local problems. We can constantly improve the world, and tools like Spacemaker show how new insights can be presented to an architect, a building owner, and eventually, perhaps even homeowners. Like computer-aided design, which has reshaped building, cinematic special effects, and logistics management, just to name a few things, the built environment analytics are a promising new technology that can help us not only solve climate issues, but to continually reduce and ultimately reverse our environmental debt. But only if we choose to make those changes. And that will take a political will that cannot be provided by a computer algorithm, at least not in democracy. So, folks, it's all on us. We have to take these actions and we have to work together to decide where we want to go. We have the tools to get there. Would you take a few minutes to share this show or any of the other 350 episodes of Sustainability in Your Ear with your friends, family, neighbors, or coworkers? Tell your boss. Tell them about your building, the fact that they could make improvements. You all are the amplifiers that spread the ideas that lead to a less wasteful world. Let folks know they can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other places that they find their podcast goodness. Folks, I appreciate your support. Please share the word. I'm Mitch Ratcliffe. We'll be back with another innovator interview soon. In the meantime, folks, take care of yourself. Take care of one another. Let's all take care of this beautiful planet of ours. Have a green day.